Is this Alec? This is your first emceeing of a Turing event?
It is indeed. And I believe we are recording now, even though sometimes it says we're recording and sometimes it doesn't. So it is recording though. So
yeah, I see recording. You got any tunes for us? You got any Spotify over there, Alec?
Throw something on here.
I feel like I just entered into a horror movie.
Let's see. I just threw it on a playlist that I used to throw on during independent challenges.
I like it. I just got back from the pool. In case you're wondering, like, Jeff, why is your hair wet in the middle of the afternoon? Took the kiddos to the neighborhood pool. Jake, what you been up to in life, man?
Busy, working, mostly
working, making electric vehicle shit.
Pretty much. I'm stealing my boss's slideshow here, so we'll see how this goes.
Stealing my boss's pause slideshow was like, I was hoping for something more exciting than slideshow at the end of that.
Oh.
You know.
No, you got
stealing my boss's house.
No, not doing too much. I got a 4-year-old daughter, so I've been hanging out with her, and it's been about it.
Very nice. It's because I called it horror music playlist, Alex. You didn't have to turn it off.
Is it too low?
Oh yeah, I can't hear anything.
I can't decide. I can't hear like you guys talk.
Oh yeah. Sure I usually put it on my Spotify slider. I put it at like 30%. 30%.
I've got mine at like 75%. Can you hear it now?
Nope. Nothing.
3 weeks ago, Jeff told me he put it at 20%. So
did you do like the share with audio thing? Because I know Zoom always used to like not share the audio with it.
When we hopped on earlier, I was asking if they could hear it, and they said they could hear it. So I hope.
Yeah. Well, no pressure now that we got the video, the slides, and all that stuff. I guess, do we have any video stuff today? Everything live?
I don't think so. I think everybody's doing live presentations. So. Can you hear the music now?
A little bit. It's like kind of choppy, like it's getting noise canceled from your
idea that music is there.
Yeah.
Island disco.
The essence of music.
Yeah.
Like a LaCroix. The essence of something that tastes good, but it doesn't.
I go to Target to get a drink to try out with my lock.
I'd rather you go to the pool and find our ball.
Right.
I said I'd rather you. Oh, sorry, forgot I'm off mute. I'm not muted.
Oh yeah, I should probably ask before this gets started. What's our actual like format for this? It's like presentation and questions, or just presentations, and we just go through all this.
However you want to do it, Jake. It's your party, man. We're just the audience here, just listening in. All right, Alec, I think we should get it started. All right, so welcome for some Alumni Showcase. Thanks for joining us this evening. We, a couple of months ago, 6 months ago or so, we were doing demo comp, and an alum asked, like, hey, can I show my project at demo comp? And it's like, no. And then we did a couple of alum projects at demo comp, and it was like, yeah, this is cool, but kind of weird. And we said, hey, let's try out doing a dedicated alumni thing for folks to talk about what they're working on, side projects. We've seen some wild, weird stuff, all kinds of things. So invited through the call out, invited folks to present today. And we have 3 sessions today. Alex going to be, I guess I'm the MC and you're the host. You're the host. I'm the MC. I don't know what. Alec knows the organizing bits, whatever name you want to give that. So Alec, you want to tell us about our 3 presentations tonight?
Yeah, we have 3 different presentations. We have 2 technical talks and a project demonstration. We are going to be starting with a couple technical talks, and then we'll get into the project demonstration.
All right, I'm into it. Who's first?
First up, we have Jake Cohen with
Jake Cohen. Look at the young Jake Cohen in that photo. That was before kids, Kids, it's like the presidency. It makes you like age twice as fast. All right, Jake. Jake, when did you come to Turing?
2018. Yeah, 2018.
The year 2018. Yeah. Mm-hmm. And then you went to work where?
I was at Comcast for a couple of years, doing kind of.
I like how I say like I'm saying, yeah, you're correct. You were, yeah.
Yeah. That's where I was. It feels like a lifetime ago now. No, I did some of their network fiber plans of like where to build new fiber lines. Some of their different financial analyst stuff there.
And then you went straight from there to EVgo?
Yep.
Or was there a middle step? Okay. And then you kind of been like getting into the data side of things over the years. Fair to say. What's your job title now?
I think it's just manager at this point. But it's
just manager.
Yeah, it's the strategic analytics team. So data science, data strategy, kind of all things data related, a little bit of data engineering, a little bit of data science, a little bit of analytics thrown in.
Pretty cool. All right. And what are you going to be talking to us about today?
I'm going to talk about how to actually build out an EV charging network. So my team, it's about 13 of us. We're kind of responsible for choosing where all of these charging station infrastructure things go. So, yeah.
All right, let's do it.
All right, I'm going to stop sharing my screen and I'll hand it over to you, Jake.
Right. All right.
Dun, dun, dun.
All right, we're loaded in here. All right. There's a lot of people who wonder about where we actually put all of these EV chargers. So kind of get to go through all of that. Just for some background here, this is kind of the ramp up of electric vehicle sales that we've seen. Something that kind of determines where we put all of our chargers is where all of the EV sales are. It's been kind of worldwide in a linear fashion. The United States kind of lagging behind everywhere else, but we expect that to kind of drastically increase year over year as supply lines kind of ramp up and more manufacturers have been able to enter that. We've seen a ton of new models like coming out this year, and so we kind of expect this to continue growing out to continuing to grow out kind of year over year up to at least like 2030 as things kind of ramp up. Normally, the reasons why it's so hard to actually build out the infrastructure is it's super expensive. It's about it can be well over $1 million per location. So a lot of investment kind of going into that. And then our margins are directly related to how many EVs are even out there on the market. So the more EV sales there are, the more we can put chargers in and the more places we can put them. And it's kind of this chicken and egg thing, because the number one reason that people don't actually want to buy an EV is they don't trust that we'll actually build out the infrastructure in time. So being able to build that out helps the car manufacturers sell more EVs. We're able to then get more customers on our network. So we actually end up working with them a lot to kind of both subsidize some of the costs, as well as to kind of handle that market pressure to make sure there's enough charging to do that. So as that kind of builds out, we end up kind of doing various forecasts, a few different sources for that we look at. But both on the high and low, we expect kind of year-over-year growth that kind of dwarfs anything that we currently see on the market. Even as the EV sales might have slowed down this year, they continue to go up and take over more and more of the market share. And it's still kind of well within our expectations for kind of what we were looking at as far as how much that goes. So currently, because of that kind of, there's a lot of OEM investment into the EV share, in the tune of like 410 billion just to build the cars, as well as some of that into charging networks through not just us, but a few different companies. Tons of government funding in as well. I think 13 states plus California are committed to 100% EV sales. I think that's been a kind of moving target for the date range, but 2030 to 2035 area. And we've got a ton of commitment from like rideshare stuff. So we've already seen Uber and Lyft really kind of make a push for people actually renting renting EVs through Uber and Lyft with kind of commercial rates that we give them on our chargers to kind of do that. So a lot of this kind of goes back and forth because we kind of speed up the EV adoption with these partnerships, and then they can help us build out as well. We've also kind of seen the price drop in EVs. Some of that has been like subsidies, but even without the subsidies, we start to see the kind of cost of them come down to where it's actually getting competitive to other fuel types of cars. And especially like in the next couple of years, I think that will be a really competitive kind of price that we've been monitoring with that. So to that point, like you can see how many charging points there are, or sorry, how much charging ports there are by state. Mostly at this point, they are kind of electric across the board. And in the lower right-hand corner, you can see that there's usually the size of sites has been going up as well. So it used to be about just like a 1 or 2 port per site. Now you're looking at anywhere from like 6 to 12 kind of stalls at any given site. Tesla's pretty much dominated the market so far, but they are still kind of trying to open up their network to handle other cars versus everyone else can kind of handle the rest of the CCS adapters or handle the Teslas through an adapter at this point. And our company is adapting NACS as well to handle Teslas natively on the network. So the big question then is, as this is building out, and we kind of try and go through how much emissions we're reducing, what we actually do to kind of help that, we need to decide where to put all of these chargers to kind of optimize that. So we currently have about 1,000 locations across 35 states. Some of those are older sites now at this point versus kind of our newer infrastructure that is like the 350 kilowatt chargers that really get kind of fast and are more competitive with like a gas station. And we ended up partnering with Pilot Flying J to kind of build out a lot of those are kind of the white dots on there as we build out their locations in there for some of the highways, while we can focus on some of the more city-based higher market areas that have more kind of the demand for charging. So there's kind of the question of how did we end up choosing all of these locations and how did we decide to put them there? So that's kind of like our mission here is to build these in the best possible thing. We only have so much money to actually build all of these sites, so we need to choose the ones that are kind of the best places, both for adapting the market as well as for just our own returns of knowing that they're going to get used and are worth actually putting in, because they're so expensive. It takes a long time to get return on a site that is just built that costs $1 million to build. So some of this has been kind of handling supply chain stuff, especially since COVID. We had a variety of supply chain issues that we've kind of gone through, a lot of host relationships with different hosts, which means we have to have a database full of every single host in the nation, where they're located and what kind of business they are, and organize that. As well as like we do government advocacy for and utility advocacy for what kind of electricity rates and how the grid should work. Because we put a lot of energy on the grid, but that also means we need to actually model and look at how much energy it's going to take to charge these cars, how much demand we're going to put on the electrical grid, and then how much that's going to cost us from the utility perspective, and what kind of cost models. Because there's, I think 6,000 different utility cost structures spread across the United States, some 500 different utilities that we end up looking at. So it's kind of a lot of large data analysis to kind of build out those calculations and understand what we're actually looking at and where we should build and how much that's going to cost us. And as we kind of go through that. And various government grants can kind of do that to kind of offset some of our costs, because some of that is not like economically feasible in certain areas. So grants kind of make up that difference. So part of our team's job is not just like choosing the best sites for how much energy is going to get used at those, but are these sites actually economically valuable to build there? Which is kind of a nice play with how many cars are being sold and where the demand is, that we're going to fill the most demand with the most economically viable sites. To that fact, a lot of our focus in where we choose to kind of weight stuff to some degree is based on multifamily homes in an area, because people in apartment complexes don't have a garage to charge their car in. So we actually see an increase in EV buyers that live in multifamily homes. We kind of have a more granular analysis that we do on this as well, where we break down different profiles of types of chargers, whether they're just traveling, whether they kind of charge at work and top up during the day, or like even people charging at home still occasionally will stop by and use their charger. So we've kind of seen this like growth year over year, both of people that live in multifamily homes, as well as kind of a public DCFC increase for total charging. So we actually see an increase in charging relative to the market as a whole for how many EVs are out there. So I guess that's kind of, I spent a lot of time on the overview. What we actually do then is we need to draw these circles on a map and say, where do we actually want to put these chargers? And how do we do that? And how do we plan that out? So in addition to multifamily, we have partnerships with various companies that we also need to kind of weight in here, where we might have a policy with Target where they want to build 500 sites. We need to choose like the top ones or priority around those. And we can kind of use that to optimize and find locations within where we want to build that also have our partners in there. So how we kind of build out a funnel is we first have to kind of estimate our market size here. Say 160,000 stalls built in the next 6 years by 2030. We then have to look at our share of the market, and then we have to move that down to what actually meets our investment criteria and what's worth it to build out of all of those stalls. And then we have a Project Swift that will be our builds for the next 5 years. And so then we kind of optimize that for the best sites that we want to focus on, or that meet certain grant requirements that have like a timeline on those grants. And so we kind of funnel that down into where we build. A lot of that is kind of integration with Salesforce. A lot of that is our own Python scripts that we've built out that models all of this. So we take the various models, we run the sites through that location to identify them, and then we do the financial estimates to kind of select those sites. And so we actually do we see a good growth, and we actually forecast very conservatively to that. So you can see that our conservative forecast line, the kind of light blue on the left, is actually way underneath the cumulative actual. Part of that is on purpose in that we actually underestimate everything that we do because we don't want to get ourselves in a financial problem where we overestimate it and then run into problems because we're not getting the return. So we're fairly conservative in where we choose things, and our models are actually built around that to kind of make up for that. And then we kind of offset that like $1 million CapEx. We can bring that down through partnerships with OEMs by getting some of these grants. And 30C is a particular grant from the government to actually build in kind of the government's version of a low income area, offsets about 25 to 30% of our construction costs to do that as well. So how we actually end up doing the network planning is we actually do this kind of automated in Python mixed with Snowflake as a backend for a lot of it, is we end up kind of estimating the overall market size for how much energy is going to be put into electric cars, how many stalls there are, and then kind of a kWh per stall per day that you can kind of expect on the network. You see a lot of fluctuation at an individual level, but kind of network-wise that evens out a lot. And we kind of do that at different geographies as well. So we used to kind of do it at state, we do it at MSA, and we have parts of our model that actually go down to like a CBG level, a census block group, which is around 2,000 people in size. So this is built out in Streamlit at the moment, as we actually have a new version we built out in Snowflake. And so that kind of automatically allows us to kind of build through this model in the geographies and apply different sensitivities to it so that we can see, even though the calculations might be kind of straightforward, it allows us to kind of do a lot of estimates on it, play with the numbers, and see kind of where we're at and how we can kind of impact that and whether we might be high or low in different areas. And then we have to actually choose our sites. So a lot of our stuff then runs through ArcGIS, through ArcPy specifically. So we have a script that goes out and runs over different areas, as that kind of helped us choose how many sites we were going to build and how big they are, and then where we place them. So it's a kind of location allocator method of looking at things to optimize our demand. So we actually had to put a ton of data into kind of a machine learning algorithm that I'll get to in a second that kind of looks at this and says, place these bubbles in a good spot based on where this highest demand is, where the tax credits are, where our partners are. And then we optimize these for kind of around the grants of things that have been released and things that haven't been released. You see some cutouts in there because we take out things that aren't eligible out of where we want something kind of in the center of this, but we take out sections because either the 30C grants aren't there. We take out things for flood zones because flood zones have additional build costs. That usually involves a lot of cement and a lot of costs associated with that. So it kind of ends up with these weird looking crop bubbles that we actually build for where our network goes. And then we run all of our financial analysts on top of that. So how we choose where those demand points look something like this. The left version is the more simplified version, and then it ends up pulling a ton of data in. So we pull in a ton of data from different sources, some of that through different APIs, some of that through our own internal databases, some of that through flat files we get from different sources, both through like NREL, from PlugShare, from our own internal data sets. And we build a giant combined panel data set. That's also all kind of done in a mix of SQL and Python that builds that out. We run a kind of random forest model with XGBoost. And this gives us predictions down to a CBG level of how much demand there is in a given area for charging. That is the basis core of where we want to place our chargers, is where there's most demand, where people need these chargers. And we look at that kind of not just at current levels, but where we expect that to be in the future, because we have data on car sales by that area that we take a look at. And so we kind of run that through multiple variations of that. And we pull in then competitors and we pull in different candidates because we can't build everything all at once. We have to build it over time. So we kind of switch through that and build some of them then we rerun that with the next ones we want to build. And we kind of optimize around that with competition for how much draw there will be from that. So we end up running this multiple times through for where we build it. And that kind of gives us not just our model, but our look at what we want to build when. Which then we can kind of release this data and it looks something like this to our site development team, where they know both like the utility that they're going to build in, kind of all of this data that we've stored in the database out of our panel set. And we can tell them, here's when it like the timeline of when it's going to be built, where it's going to be built, what the utility is, and then they can see actually like the NPV and a target CapEx that we've also estimated using some of our like internal tools that we've been able to run at scale to run the financials through all of this. And that way we can kind of look at that and give them an estimate of the sites, make sure if there's problems, we fail really fast at it, because we have to tell utilities we're going to build the site at least 9 months in advance to get stuff from the utility. So we have to be ahead of the curve and make sure we know where we're going to be building the next 2 years, 4 years, 5 years out. And so kind of this is all essentially built in Python with ArcGIS to kind of get there as we do all of that kind of SQL work to build these panel data sets and get to that. And as we kind of make changes to our models, we can see that kind of NPV number change for what is actually financially viable. I think I'm a little bit over time here, so I'll try and wrap this up. We end up looking at a ton of utilities, 6,000 rates, 387 MSAs. It's a large data set, and we need to run financials on all of that and understand the demand in the area, the costs, the construction costs, our call center costs, and kind of put that all together and model how profitable this site is. And that's all been built into a web app that can automatically run these and update them and see kind of how we're comparing to our model. So we end up looking at something that looks like this display that's pulled out of our Django web app. And it has like our utilization, how much kWh we've sold versus expected, kind of with a percent to target KPI dashboard that we built out now for like a full line item P&L to see how we're performing on various metrics and can dig into anything where we're off or doing better than average and should adjust. And kind of seeing, and this allows us to kind of adjust our model going forward as we feed this data then back into our models. Or into looking at like what sites maybe we shouldn't continue if the host isn't doing it, if we're not getting the expected revenue from a site. For the most part, our new chargers would just kind of stay in there, or if we should reinvest and actually invest in more sites or larger sites in that area as well. So yeah, and you can kind of see, hopefully we seem to be doing pretty well across the network so far with our modeling as we kind of go through that. So, yeah. So
I have a couple questions, Jake.
You go for it.
What's the end game like? You know, if everything is going great for the next 10, 15, 20 years, is it like EVgo is going to have a charger, like every block has a charger, you know, or does it reach the same density as gas stations would do currently? Or yeah, like
in theory it could eventually get to the point of like where gas stations are. Currently it's kind of a lagging model. First EVs are sold, then EV chargers are built. We ideally would kind of want to get a little bit ahead of the curve and make sure we're building at the rate cars are sold. So because there's the financials of it kind of make it so that as more cars are sold, more chargers suddenly become viable. If there's less cars, less chargers. So at some point, we actually want to match the number of, like, we want to match the demand. So around 2030-ish, you should actually see a point at which like I think in California currently, Electrify America just announced that they're only allowing charging up to 85% of a car. We want to get to the point where that's kind of like not a problem, because that means you can put more chargers there because people want to charge more than the chargers can actually do. But you also don't want to be a point at which you built the chargers, but there's not enough people on them. So we kind of want to match that. Usually we expect to be able to do that by kind of 2030, but usually it's a couple years behind. So 2032 to 2035, you should see new chargers come in based on the number of cars sold in an area, and we'll hit kind of an equilibrium between the two. I don't know if that quite answers your question. I think that the estimate I showed, like market wide, was 160,000 by 2030, which is kind of what across the industry everyone's looking at. Those models have kind of changed. We work with NREL, the National Energy Lab. So we've kind of talked to them about like their model for it as well. And we do actually end up partnering with our competitors for electricity rate and grid stuff, because that's something where we all kind of have the same thing that we look at for that.
Interesting. Chantal.
Hi there. I did have a question. How receptive are companies to partnering with EV charging stations at this time?
It depends entirely on the company, to be honest. So some, I think we are on the more expensive side for, well, let me back up. There's two types of partnerships. One is what we used to call like our extend deals, where the company actually owns the charger, so they pay for the construction cost, and then they are the ones that kind of get that revenue over time. We are on the more expensive end of the build, but we also have the higher powered chargers. So we didn't actually see a lot with that. So we, at this point, kind of own our own chargers and get the revenue from that is our main focus. Pilot Flying J has all those truck stops along the highways. So they are very much in that kind of extend version of that, and are very receptive to partnering, as they've built essentially our partner for building out all of those chargers. As for the rest of the hosts, it kind of varies greatly, because some hosts are actually really interested in it, just from like having it there, or like from the idea of like green energy. Some places are just kind of committed to it. I know Amazon has their own delivery fleet that they have to charge on top of kind of having all of their chargers at Whole Foods. So we see some large commitments from some of those larger companies. Smaller companies tend to go toward more foot traffic type things. So having a charger brings in foot traffic, but we also take up a parking spot for like one of their parking areas. So they don't have as many people to kind of park there. So we can kind of bring in traffic to them, but it's a lot of negotiation too, because there's rent we pay on top of that. So I'm not the best person to actually answer that, because I more provide the here's the list of all of the possible partners and all the businesses in there. So we do provide like a list to our site dev team of like, here's the area you want you to build. Here's every single business in there and every single contact that you could contact, like property owner. But it varies a lot, and given like the time frame and cost, it's also a lot as well. And everyone kind of has different concerns. So
Yeah, that definitely put it into perspective, because I know some charging stations start at 6 p.m. and finish at 6 a.m. Just because it's after work hours and they use their parking lot and for employees during the day, and then for charging at night.
That also could be related to energy rates as well, as it's not as much in residential, but you're starting to see it more as time of use costs. So our costs during the day are sometimes different than at night. There's actually like one utility in, I think, Utah that actually pays us money to use electricity from like 11 p.m. to 6 a.m. because they have more energy than the grid can handle. But there's also super expensive areas New York, Massachusetts specifically have huge electricity costs, comparatively speaking. But that changes. So we'll actually we're trying to get more sophisticated in our pricing to kind of handle that. So you should actually see prices kind of more reflect how much energy actually costs on the grid going forward. Just because as people get more sophisticated, the prices will kind of narrow based on that energy cost as the major factor in there. And our costs at 11 a.m. are not the same as 5 p.m. are not the same as 11 p.m. In very different ways.
Thanks. We'll get one last question from Pete Whitney. How's it go, Pete? I don't know. Last question.
Hi. I was just wondering, do you guys take distance into account, like how far you can go on a main highway before you have to charge again?
Yes. We have our own model for so part of the infrastructure bill that was passed, there was like a 30C area that I talked about that is kind of the building in low income area. There's also a NEVI funding, which is more corridor areas, essentially, if you want to think highways away from cities. We have our own definition from that. Each state also has its own definition from that. So we do a lot of things in ArcGIS because we have a lot of map layers. Both we have maps of where utilities serve, where those are. So we have different estimates for how much charging there is in kind of those highway corridor areas than we do versus like in a city. But that NEVI program also offsets 80% of like a construction cost. There's only been 8 sites in the US that have been built with that so far. Mostly Pilot Flying J through us, actually. But that is something that we kind of look at with distance. We also look at distance for impact of how far someone is willing to drive to a station. Kind of like, are they willing to drive like 1 mile versus 3 miles versus 5 versus 10? Just as an example in there. So we use not just like as the crow flies, we can do like drive distance by how far it actually takes to drive on a road to get to somewhere. And then we see kind of a fall off is most people are willing to drive within a mile, but only say like 80% might drive like only like 20% might drive over 5 miles kind of thing. And we look at pricing impacts to that as well. Like, is someone willing to drive farther for a better price on a charger? So that's kind of impacted all of our models as well. We have a separate pricing team that kind of looks at that. But it's very much an aspect of that is both drive distance for how far from someone's work, how far from someone's home, is it along their travel route, and are they willing to drive for kind of price or ease of use?
All right. Thanks, Jake.
Yeah.
Now I know a lot more. I formerly knew zero about EV charging, and now I know slightly more. No, but it's cool. And appreciate like the data side of things. So thanks for sharing. And next up, I think we got Jordan second. Is that right?
Yes. Hello, hello. And now I know about
hello.
ArcGIS crop bubbles. Thank you very much. That was very exciting to learn about. Hi, I'm Jordan. I am going to be presenting to you today on the thrilling topic of certificates and cipher suites. So everyone adjust your seat, adjust your posture, take a drink of that water, and we
About to
are
get nerdy, even nerdier.
That's right.
I'll pass it to you here.
Thank you very much. All right, let me get this going. All right, so today I am going to be talking to you about this topic, right? Grant browser access to screen recording. Oh no, are you kidding me? See, this is crazy. Okay, let's see. Grant access to
Real-time debugging, you know?
Oh my gosh. Okay. In your system's preferences, give your web browser privacy permissions. 1 minute. Sorry, I haven't used my Turing laptop in a while.
Okay.
Now you get to watch a real person panic. Let's see here. Okay. Burp, burp, burp. Go to that thing. Go to that thing. Where is that thing? Go to Chrome. Search Chrome. Okay. In the interest of time, did we want to swap the order and have
Yeah, we can come
our
back.
third presenter go?
Yeah, let's
Well,
do that.
I fix that. All right, let's do that, and I'll keep you on the edge of your seat with certificates and cyber suites.
Appreciate it. Rastam, I heard you got pressured into this presentation. Is that true?
Shout out Danny. Yes.
What was
a
the
little bit.
nature of the pressuring? Was it like, if you don't present, we're not gonna be friends anymore, or like you're a bad person, or how did that go?
No, he just he asked me.
Okay.
He just posted on LinkedIn. He's like, you should present this on Turing. I was like, all right, cool. And then he linked me again on the Turing Slack, just in case I didn't see the message on
Sweet.
LinkedIn. So he is
There you
persistent.
go. All right. Well, tell us about what you're showing us tonight.
Yeah, so I've been working on a side project called Dcord. I'll give you the overview and then we'll go through a demo and then we'll do a technical overview of the components of it. So let me just pull up my notes. Okay, so it was kind of like introduce yourself. I'm the only person working on this project right now. And pretty much what Dcord is in simplified sense is it just records your screen or whatever window you want recorded. So let's say you have Xcode or Visual Studio or Sublime and you want to record it. You can choose the window or the entire screen. And then what it does is it uploads it to your cloud provider of choice. So right now I have Google Drive set up, but eventually going to get Dropbox and a couple other ones set up. And then kind of the reason why this was born was I have a buddy who has a startup, and it has to do with PII information. So it's information that can't be shared on certain avenues. So it's like HIPAA compliant. And so what Loom does is the exact same thing, except for they store the videos on their servers. So, and they're not HIPAA compliant currently. So if they wanted to share that video, they would have to do it manually and then upload it to Drive and then change the permissions and then send it off to their teammates. So he was just like, this is a real big time sink. And so he was like, can you build a native OS app that can fix this? And I'll be your first client. So I was like, yeah, I have some extra time on my hands. I'll go ahead and give this a go. No formal training. And that's kind of how Dcord was born. So
Awesome.
I will, share and then give y'all a preview. Let's see, share desktop. Cool. Can we see my screen? Whoops. Yeah.
Yep. You got the whole desktop right now? Yep.
Cool. So pretty much all it is it's a widget in the top. If you can see this that I'm hovering over in the top, this is how you sign in. This is the intro into the app. And then it asks you to sign in with Google. We go through, we sign in. This is rough. So then you authenticate, and then basically what's going to happen now is it's going to ask you to pay. I need to get a window set up so that it basically says, hey, here's the app, here's the walkthrough, and if you'd like to pay, you can pay. And then pretty much you subscribe here with my fake credit card, so I don't actually pay anything. And then what that's going to do is that's going to bring back up the application here in a second. And now Dcord has the information available to screen record. So if I click on this, now I get different options. I have Zoom open and I have my display currently. And so I have the option to basically record either of these or my whole entire display. And then we have preferences. So you can then tune like where you want it to be saved on your local laptop. you have I integrated OpenAI in order to rename the file if you didn't want to just have it as like recording at and then timestamp, because that doesn't give any information about what you're recording. And it's also like you would have to go through and update it manually. So I added that. We have audio settings where you can change them, video settings of frames per second, quality, etc. Some keyboard shortcuts for video recording, and then kind of an other, but there's more to come on that page. So then we basically record the screen. We see that it switches here, takes a second, then it shows you like the file size and how long that you're recording for. And then we'll stop that, and we should, keyword should. Well, there's a notification that comes up here that basically says that it's been uploaded to Google, and then it copies the URL, the shareable URL to your clipboard, so that you can go ahead and paste it into somewhere, and now you have the video directly loaded in there, which, yeah. And so it's just a shortcut. Now, I will talk about architecture. Let's talk through that. So I built this as a native OS app using Swift and Swift UI, just because I needed to not store it on any servers. And so it just basically taps into storing it on the user's laptop. Swift UI is just for the screens that you see, as well as these NS menu items up here and the little windows that pop up. And so the flow went, you log in with Google, it takes you over as you log in, come back. That goes to Firebase authentication, which then comes back to my app, authenticates you. Then it's like, hey, have you paid? It'll go to the Firestore, which is a NoSQL database. And if you haven't paid, it'll pop you over to Stripe. It'll have you pay just like we did. It'll hit a function, the function will update Firestore, bring you back into the app. And then you have full access to everything inside there. So again, I used OpenAI. So what it does is it takes the first screen, and then the middle screen, and then the last screen of the video, and it sends it to AI with a prompt, OpenAI, and then it gives you back a recording name. Now, you're probably wondering, okay, it's HIPAA compliant. OpenAI, is it HIPAA compliant? Yes. So if you sign up for a business account with OpenAI, there are HIPAA compliant API keys. So you would just use your own API key that's HIPAA compliant in order to rename the file. And you obviously don't have to use it. And then we use Keychain locally to store like, hey, you paid. And then whenever it goes out and it checks to see if you paid again, it stores it in Keychain. And so, yeah, future iterations, I definitely want to report a bug feature. I have not really coded in Swift. I literally use ChatGPT to code all of this. I have not learned anything. So that's fun. Makes debugging very difficult. But I got to where I got. And let's see, I want to have like a previous videos recorded option over here so that you can quickly like search through and see what you've recorded, click it, and then copy the URL. You know, integrate Dropbox, OneDrive, Carbonite, all these HIPAA compliant cloud storage options. And then we get into the nerdy, which is like video compression algorithms, making sure that the file is extremely small. It gets uploaded. We need to get transportation layer security for encryption in transit, so that when I do send it off to, let's say, Google Drive, it's encrypted. So that's another checklist based off HIPAA compliance, Googling. And so, yeah, it's kind of on the roadmap. There's a bunch of other languages, like I could have went with Objective-C, or there's a couple other like JavaScript frameworks that you can tap into native OS. But I figured if I'm going to be doing the nitty gritty of like compression algorithms and all these things, I might as well go to the lowest layer in order to manipulate things and have the most access over, because I don't know if they have access over it. So went the difficult route. I'm actually enjoying it because it's teaching me a lot about like how Mac does things on the computer. And then, yeah, I've like learned a lot about ChatGPT and prompting because that's extremely difficult when you don't know what you don't know. You're trying to get it to work. I definitely have made friends with ChatGPT, but also yelled at it a little bit. So, yeah, that's the application.
I like that you claim to have not learned anything. That was the most
About-
offensive part of your presentation, I guess. I just checked. It was interesting with the OpenAI integration. The file naming seems like a very small, like that seems like a lot of work to get some AI generated file names. I was curious when you're talking about like future features, if you're planning or thinking about like piping video into OpenAI to generate transcripts or like bookmarks or that kind of stuff.
Yeah, I haven't thought about that. I guess if there's a demand for it when I release this, then yeah.
Yeah, or like pull out like key. I don't know about OpenAI's video processing. I would imagine it's like advancing pretty quickly, but yeah, it's interesting to think about, like if you were going to pull thumbnails of a video, you would just kind of pull, I don't know, random thumbnails or every 3 minutes or whatever. But with AI, you could hypothetically coach it into recognizing what a notable thumbnail looks like. And so like notable moments kind of could be interesting to see what you get out. It might just be bullshit, but could be cool.
Or just get some key points out of there too.
Yeah.
Analyze the voice, and then because it does record as you're talking through things. So record that and then take a keynote so that they have a list of things to pay attention to while watching the video.
Yeah. It also makes me wonder, like, if it'd be possible to do kind of automated editing. Like if you were in a video, say you're recording voice, right? And you could be like, go back to 30 seconds and now continue. You know what I mean? And like have OpenAI like clip that out would be pretty cool. I don't know. So
one day,
if you need more brainstorming, I can come up with more ideas for you. But super cool. Love seeing folks do things on like non-web platforms, and just experimenting and learning how that works. So thanks for sharing it with us. And yeah, keep us in the loop, as you push forward. Definitely gonna have to raise prices. $2 a month. Okay, come on. That's ridiculous. But no, we're getting there. Awesome. Well, thanks, Rasta. Next, back to the Jordan time.
It's me. Hello.
It's me.
That project really is great because we use WebEx at my work, and it's just, you can't share your screen. You can't share anything. It's so tough. You can't share your calendar with your manager. So having that capability to sort of see what you can't share also is really cool. So yeah, great ideas there. All right, I am back with certificates and cipher suites, and I am hopefully ready to go here.
Nice.
Huzzah.
It's
All
in.
right. We did it. Perfect. So certificates and cipher suites. Let's take a minute to just quietly read these definitions on the right-hand corner while I tell you a little bit about myself. I am Jordan. I went to Turing, started in 2201, moved on to 2203 after I decided that Mod 2 was very difficult and I needed to repeat. So I'm a proud repeater, and I'll tell you what, I definitely know dot reduce very well. I am excited today to be presenting to you. I work at a company called Akamai Technologies. They are a CDN, which is a content delivery network company that do a lot of work in security as well. So this is like the job that you go to Turing for. This is like I made it, I feel like, in life. And every day I'm grateful for it. So I just want to give a little shout out to Turing because it really, really living the dream right now. First job out of Turing, I was a software engineer at Dish for about a year and some change. I learned a lot there. I was really lucky enough to be able to work with my ROC and my accountability buddy and a kid from my cohort. So that was a really fun sort of after Turing party that we had every single day. It was fantastic. But yeah, my current job now, I'm a technical project manager. And so I bridge the gap from our customers who are large retail customers, e-commerce stores and sites, airlines, banks, all kinds. And I bridge the gap between their security teams and then our internal DevOps teams, security architects, solutions architects that are actually creating and implementing the code. Something that I learned at both of these jobs was how important certificates were. Why are certificates important? Why do they matter? Right? Security is number one. We just heard about, encryption and making sure that we have secure information for PII and making sure that we have like a way for data to get from one place to the next in a really secure way. So certificates are going to be crucial in helping you do that at any company that you're at after Turing. Authentication, right? We're wanting to make sure that certificates can prove, if you will, that a company, for instance, Target was mentioned, right? We want to make sure that Target is Target and we're not going on to some fake phishing website and putting our personal information in there and it's not actually the brand that we trust, right? So that authentication, that data integrity, that is really, really important reasons why you should care about certificates. This is a lot on the screen. I recognize that. You might have seen a couple of networking talks with Jeff or how the web works. So some of this should look pretty familiar to you. We have a client and a server, right? We have a lot of those back and forth connections. We know that we established that TCP connection in the beginning. And then from there, we have our three-way handshake. So establishing trust is this first step in getting that. These are issued by certificate authorities. When the certificate is issued, a public and private key are created from here. Thirdly, we have this sort of client hello, right? Hello. It's the user's browser. The client sends a request to the server, including all of the information about the supported cipher suites, the SSL, the TLS versions, right? The secure socket layer. And then we have this response with its chosen cipher suite. So while all of this is happening, we're getting verification. We're making sure that the correct data is being encrypted and transferred. And then there's this key exchange that happens towards the end. The client and the server are using the public key to securely exchange a session key, which is going to be used for encrypting this data. So these session keys, both parties create one and they share that information there. Towards the end, we terminate the session and a new handshake process begins for any time that you are accessing a site on the internet here. It's a lot. You can Google the image more. They're everywhere. You can look for a nice high-level overview if you like. Pardon, this image is a little blurry here, but I love the flow of the workflow of this, this image. So, right, we have our customer, our client on the left here. And so we know that these SSL certs work based on this public key infrastructure. So this method involves these cryptographic keys, these public and private keys. And here we can see the flow of all of this. So we set up the SSL session. It gets to our server here. From the server is giving back the origin certificate. So we're checking validity of the cert. Are you who you say you are? Is this the correct certification? Is the information matching what it's being requested by? Is this signed by somebody that the user is trusting? If that all passes, then we start the encryption process here. And then we deliver the information back and forth again until that session ends. So this is just another visual for the example that we just saw before. So what kind of certificates are there? There's three main SSL and TLS certificates. So these are DV certs, OV certs, and EV certs. We have a very quick issuance for these DV certs. They're typically issued within minutes from a certificate authority. You need to complete a domain validation in order to renew or get these certificates. So that looks as simple as just making sure that you have some Acme challenge for your user. We have the next level up, which is the OV certificates, the organization validation. And it's exactly like what it sounds like, right? We're making sure that the organization is who they say they are. That Target example that I just mentioned, that's a good example of an OV certificate. I don't know if they actually use an OV certificate, probably EV, but that in that example, that's what it is. So think business websites, informational websites. Security level is higher than a DV. This includes business information in the certificate. We can see this by, previously we could see this by a lock, like a little padlock icon, right? I think it just stopped like in 2019. You could go to a website and see that it had a little lock and you were safe. So EV, extended validation, is the most secure, right? One level up. So this is rigorous validation. This is every time you renew your certificate, you're getting legal, physical, operational existence proof. So you're mailing something to that physical address. You're making the phone call. You're making sure that in the yellow pages, this business is who they say they are, right? You wouldn't want to hand out just a willy-nilly certificate to Chase Bank if they were not Chase Bank indeed. So EVs are highly ready in the financial institution world there. We also can see on this image on the left here, we have different standard SSLs and wildcard SSLs. So there's different SANs that can sit on one certificate. So you can have a one-to-one, you can have, depending on your company, up to 100 different host names and domains on one different certificate as well. With the wildcards, it's great because you have a lot of host names for one domain, usually like you have the blog, right, or the shop, or the if you're an airline company, you have booking flights, or you have managing your flight, or you have reaching out to someone for help. So all the different wildcard SSL domains are there as well. So we're talking about certificates and cipher suites, right? So let's get a little more detailed. This is similar image to what we saw before with our three-way handshake, right? And we have our HTTP request and all of our encryption. So we know that, excuse me. So we know that we have certificates and they rely heavily on this information here in the beginning. We have that key exchange that we talked about. So cipher suites, they're a combination of algorithms that work together to secure these network connections. So the client and the server, they have to agree on a protocol to encrypt the data. The cipher suites, what they do is they define that protocol. They lay out how it's going to be. Here's exactly what we're going to do. And they say that's, and then they give the information that way. So SSL certificates, again, those digital files, they're verifying your website's identity. They're allowing for that encrypted connection between your website and the web browser. And the cipher suites, those are those set of instructions that help secure the network connection using the SSL layer or the TLS layer here. So how are they related again? Like, are they two separate things? They're pretty similar. One needs the other. So we have this key exchange algorithm that we can see here. This is how it's made up on the bottom. We see our protocol. This should look a little familiar to you, this TLS protocol. We have a key exchange. This key exchange determines how keys are exchanged between the parties. So we see here it's RSA. Another example could be DH or ECDHE. This is probably sounding like Greek to you. This is just to get you a little familiar and aware of that these even exist. So next we have encryption algorithms, right? This third part here. And that specifies how your data is encrypted during the transmission. So we could have the AES here. We could have 3DES. Last comes this hash part. This is the integrity of your messages. So you'll see this SHA 256 quite a lot in certificates if you go digging. And I do encourage you to go digging. In fact, we have a website, a random website pulled up here. And I encourage you to whatever windows and tabs you have open right now, if you're multitasking, have a little look. in your browser, right? Do you see this little dot with a line thing? Hover over it, view site information. We can see that Turing site connection is secure, right? We can click on that and we see, hey, Turing has a valid cert. That's awesome. If you click on that, we can actually go in and see some information there. There's its common name, right? That's the name of its certificate, right? We can see that it uses Let's Encrypt, which is a certificate authority that helps to issue these certificates. I can see they just renewed their certificate. Awesome. So they're good till October 1st. And from the short duration, I can probably see that it's a DV cert. We can see that SHA 256 that we just saw from our Cypher suite, right? This is giving us a lot of information just on this general page. Here's our cert and public key. If we go into the details, we can actually see the chain here, the certificate chain. So from R10, we're getting that Turing.edu cert, and we can actually see all different kinds of stuff. Look, there's some information from their algorithm, their issuers, all kinds. If you go to another site, I'm going on vacation tomorrow. I'm very excited. So if we see here, same thing, right? Their connection's secure, their cert is valid. We can click and just kind of see the different things they have going on. So they actually have Amazon as their origin provider here. So we can see that trust chain goes all the way to the root certificate up to the certificate authority here. And they have some more information there. So look around, certs are all around you. Let's see, let's go back to this presentation. Oh, did it go? Where did it go? Boop. Okay, hold on. Where did it go? Anyways, if you are in charge of renewing your certs, or perhaps you are on the team that does certificate ops, you may notice that you have, hold on one sec. You may notice that you have some responsibilities, and those responsibilities are very important because you want to make sure, oh my goodness, sorry, I'm having some, it's vacation already for me, really. Okay, you want to make sure that you're aware of different Cypher suites, right? So you have a lot of options when it comes to different versions, and sometimes your Cypher suites might change for a customer. So you may have you may have to choose from this list of pre-built Cypher suites. They all provide this different mixture of each of these different things. Here's some examples of different encryption or authentication types. We can see here for this RSA, it's actually split, right? So that's pretty unique in that as well. If you're in charge of certificates, don't let them expire. These are some real life examples of cascade of problems, right? We have Shopify, a well-known brand, Microsoft, Spotify, Starlink, even, can you believe it? That experience downtime. If your certificate is expiring or expires, your site is down. That is a big deal. So this is one of the main reasons why, if you are in charge of certificates like I am, you make sure you have some system in place to have some automation, some DevOps, you're working with the CertOps teams, and you have a really good plan on keeping those certs renewed. After this, I'd love to hear if Jeff knows how they renew their certificates at Turing. But yeah, thank you all so much for listening about certificates and Cypher suites. I hope you at least are aware that they exist now if you weren't before.
Thanks, Jordan. So when I was in high school, I thought it was like nerd cool that my favorite book was Applied Cryptography. Have you ever heard of that book?
Yeah.
Okay. It's like if you haven't, if you find these things interesting, I recommend it to people. It's like the old school, it's like the Old Testament of cryptography. And yeah, I was thinking when you're talking about problems here at the end, it was reminding me, like, as a end user, I think one of the certificate / like security exchange problems that you're most likely to run into is if your clock is ever really wrong. Like if for one reason or another your laptop has a
My
wrong
Turing
time or date,
Yeah. The
then
Turing
like
laptop does that.
your SSL will fail because in the negotiation back and forth, the servers could be like, nah, that's not the day and time. Like your shit is all messed up. I'm not speaking to you. Partly because there could hypothetically be like different attacks by spoofing certain times or dates or trying to do like repeats. And anyway, I think it's cool. Have you like, how did you get into this space? Was it like by accident or were you like, this is
It was
interesting?
it was weird. Turing, I remember one time in mod 2, I can't escape it. They're like, learn about dot reduce and you get 9 minutes and then you're going to present to your peers on this thing and you're like, what is that? I have no clue. And so Turing really did teach me to just learn it really quick and learn how to do it and figure it out and present on it. So when I was at my first job at Dish Network, they're like, we need someone to deal with the firewalls and update the certs. And I was like, I don't know what that is, but I'll do it.
Give me
I'm
9 minutes. I'll figure it out.
Yeah, and from there, like taking that opportunity and just saying yes and learning a little bit about DigiCert and Let's Encrypt and all of that. I threw it on my resume because I was like, I know this, I'm doing it. And that's honestly how I got my second job, which I love so much right now because I said that I had certificate experience and I'm a novice. Like I'm like, there's, a lot to learn actually, but yeah, just saying yes and being open to like just leaning into what you don't know.
It's an interesting point with a lot of niches or specializations or whatever. There's no place to get people who know that, right?
Yeah.
Like there's no, you're like, oh, we need to hire 10 certificate people. Like, where are you going to go? There's no grad degree or whatever. And so once if you stumble your way or choose your way into one of these little paths, then all of a sudden, like you're like, yeah, I did this for 90 days or whatever. And they're like, well, that's 90 days more than everyone else. Come on in and have this job, Jordan.
Totally. It's not the JavaScript that got me any of the jobs. Like I wasn't a great JavaScript curator from the heavens to write JavaScript for the rest of my life. Like, but I know that I can learn things really quickly now. And I know that I can, I'm like, yeah, I'll learn Python. Sure. I'll implement it. I'll help the DevOps team. Sure. So just saying yes and being open. That's what Turing taught me.
I love it. Well, thanks for sharing all this with us this evening. And yeah, just we'll like emphasize again, it's interesting, like cryptography was came up a couple times tonight, like super interesting domain if you're looking for nerdy research or side projects or whatever, all kinds of things. And the answer to your question is kind of a disappointing one about our certificate, which is it's built into our web host platform.
Perfect.
It used to be back in the day. I don't know if you've heard this story. Well, at least, okay, I believe this story to be true. Okay. Which is that back before Let's Encrypt existed and so forth, like getting certificates used to be a very slow process, like weeks. And because of that, very few sites used HTTPS. And then it all turned in a relatively short period of time when this plugin for Firefox came out called Firesheep. Have you ever heard this story, Jordan?
Actually, yes.
Yeah. And so Firesheep allows you to like hijack other people's cookies on your local network. And this was happening at the same time as the like proliferation of public Wi-Fi, of like coffee shop Wi-Fi and so forth. And so I, for my research purposes, obviously had to install Firesheep and try it out. I was on an airplane Wi-Fi and ran Firesheep for a couple minutes. And it was one of those moments where kind of like my heart sunk and I was like, whoa. Because I was just clicking on cookies and it was like, now you're in this person's email. Now you're in this person's bank account. Now you're in this Netflix, whatever, it was pretty wild. And so in a relatively short period of time, Google used their influence because they said they were going to prioritize SSL results in Google search. And so every business person was like, I don't know what SSL is, but we better get it right now. And so then we all had to get it right now. And thankfully, some of these certificate authorities made it easier and easier to like get certificates and keep them updated and so forth. So now, yeah, there's almost no reason to not use SSL, except just straight up laziness. So
Google has a brand, like in November, Google's changing a lot of stuff about their certificate authorities too. Should Google that, everybody. It's very interesting.
all
post it.
right. Well, thanks for sharing your knowledge with us, Jordan. And Alec, that's it for us tonight.
Yeah, it seems
You
like
got
it.
any parting thoughts here?
No, just honestly, as a Turing alum myself, it's super cool to see all the different like industries and areas that people are getting into. And I think that's one of the cool things about the Alumni Showcase event is like not only do you get to see cool projects and cool things that people are working on, but it just exposes you to like, wow, I had no idea you could kind of like take this and go that direction or take this and go that direction. So I know that was one of the cool things about tech for me. And I think this really put that on display for me. So yeah, thanks everybody.
Thanks for organizing, Alec. And I think that's it for tonight. Thanks y'all for joining us. We'll post some videos and things in the near future here and talk to y'all soon.
Thanks everybody.
And so
Bye.
renew your certs.
Renew your certs.